Hello, Accelerated Chemistry. This is Mr. Spurk, and this is our last section for Chapter 13, Changes of State. So we've talked about a few other changes of state, freezing, melting, vaporization. So now we're going to talk about sublimation. The change of a substance from a solid to a vapor without passing through the liquid state is called sublimation. Sublimation can occur because solids, like liquids, have a vapor pressure. Sublimation occurs in solids with vapor pressures that exceed atmospheric pressure at or near room temperature. So from a solid straight to a vapor, we have sublimation, and from a vapor right to a solid, we have deposition. So sublimation has many useful applications. Solid carbon dioxide, otherwise known as dry ice, is often used as a coolant for goods such as ice cream, which must remain frozen during shipment. Because it sublimes, it does not produce a liquid as ordinary ice does when it melts. As it changes state, dry ice absorbs heat, keeping materials nearby cool and dry. So we're going to talk about phase diagrams in this section. The relationships among the solid, liquid, and vapor states, or the phases, of a substance in a sealed container can be represented in one single graph. This graph is called a phase diagram. A phase diagram gives the conditions of temperature and pressure at which a substance exists as a solid, liquid, or gas. The conditions of pressure and temperature at which two phases exist in equilibrium are indicated on the phase diagram by a line separating the phases. So, along the line at those pressures and temperatures that fall on the line, both phases exist in equilibrium. So we can look at this phase diagram of water over here on the right. See that purple zone on the left is for solids, the green is for liquid, and vapor is in pink. Pressure is along the y-axis and temperature is along the x-axis. The phase diagram of water shows the relationship among pressure, temperature, and the physical states of water. In each of the curving regions of the phase diagram, water is in a single phase. So in those colored zones, it only exists as that phase. The curving line that separates water's vapor phase from its liquid phase describes the equilibrium conditions for liquid and vapor. So this curving line between the liquid and the vapor is where we see both phases existing in equilibrium. The other two lines describe the conditions for equilibrium between liquid water and ice. So that would be between liquid and solid. So this line here. And the last line is between water vapor and ice. So this would be sublimation, a solid right to a vapor across that green line. The point on the diagram at which all three lines meet is called the triple point. So that's this zone right there where all three of those lines meet. The triple point describes the only set of conditions at which all three phases can exist in equilibrium with one another. For water, the triple point is at a temperature of 0.016 degrees C and a pressure of 0.61 kPa. This flask over here on the right, this is a round bottom flask. That's why it looks a spherical shape. This flask is at the triple point. Freezing, melting, and boiling and condensation are all occurring at the same time in the flask. By referring to the phase diagram of water, you can determine what happens if you melt ice or boil water at pressures less than 101 kPa. A decrease in pressure lowers the boiling point and raises the melting point. An increase in pressure will raise the boiling point and lower the melting point. So basically, when we look at these, we want to think about it like a coordinate system. We're going to be given a pressure and we're going to be given a temperature. So we might follow along those lines and figure out where they meet to figure out what phase it is at that point. And so then let's say if we're at this green dot and we increase the temperature to 90 degrees C at that same temperature, we're going to go across, and we see that we would then be in the vapor phase. So we're just going to be looking at different coordinates and determining what changes occur when we look at different coordinates. Below the triple point, the vapor and liquid cannot exist in equilibrium. Increasing the pressure won't change the vapor to a liquid. The solid and the vapor are in equilibrium at temperatures below 0.016 degrees C. So that's going to be this line down here. With an increase in pressure, the vapor begins to behave more like a solid. So in review, sublimation occurs in solids with vapor pressures that exceed atmospheric pressure at or near room temperature. The conditions of pressure and temperature at which two phases exist in equilibrium are indicated on a phase diagram by a line separating the two regions representing the phases. And that's it for chapter 13. Pretty short and sweet. As always, all the information on these slides has been acquired and adapted from pearsonchemistry.com, the 2012 edition of the textbook, and the resources CD. Have a good rest of your day, everybody.